Oh.
Makes sense.
So
That's
this is
cool.
done in a test tube. CRISPR is done in the cell.
That's really cool.
But it's not nearly as specific.
Wait, CRISPR
CRISPR is not
specific?
specific.
CRISPR is not
Oh.
specific
Oh.
right now.
Huh.
So there's still a higher level of accuracy when you're doing it outside the cell.
Huh.
Do you want me to restart?
But
Or-
Okay.
That's opposite of that.
Yeah.
Okay, are we recording?
It was recording like 10 seconds ago.
You're recording 10 seconds ago.
Do you want me to restart?
You got wrecked.
Beautiful.
Okay.
So, pGLO is a circular piece of DNA. We've covered this already, but let's just go over it again. There are many genes on it. We are going to be specifically talking about 3. We have the ORI, which is the origin of replication. That is a sequence of DNA, like it's letters like T's, G's, C's, and A's, whatever. And basically, that's going to be the same as the part of the bacterial DNA that gets copied. So there's going to be an enzyme. It's going to have an active site. That active site is going to recognize a piece of bacterial DNA and start copying. The same thing is going to happen on the ORI. You're going to have an enzyme. It's going to recognize the ORI, and it's going to start copying. Okay, that bacterial. So, anytime the bacteria makes its own DNA, it's going to copy the plasmid as well. So, if the bacteria splits in half and produces 2 new bacteria, it's going to produce 2 new plasmids. That's how we're going to grow it up, and that's how we're going to make a ton of it without having to order 10 vials per student. Okay, the other gene is called the green fluorescent protein gene. It codes for a protein called the green fluorescent protein. It is green and fluorescent.
And a protein.
And a protein. Directly in front of the GFP gene is something called an inducer. Specifically, this is an ERA inducer or an ERA operon. Operon is just a set of genes together that generally allow you to control genes. This basically means that if I add ERA to this, GFP will be produced. If I don't add ERA to this, GFP will not be produced. ERA's full name is arabinose. If it is arabinose, what kind of macromolecule is it? Ose. Think words that end in ose.
Glucose.
It's a carbohydrate. What is it composed of?
Carbon, hydrogen.
Carbon, hydrogen, and oxygen. In what ratio?
1 to 1.
1 to 1. Is it polar or hydrophobic?
Polar.
Negative.
Polar. 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 Polar.
No, those are liquids.
Polar.
Very polar.
Is turned completely.
Okay.
I got that wrong.
Yeah,
Alright.
I think you could
The
make
other
it
enzyme it has
like
is beta-lactamase. Do we know what beta-lactamase does?
Here, check it out. This
Arabinose is a
It
carbohydrate.
is not
It's very polar. What else did we say?
And to me, anti-ampicillin is like this thing and this thing, and then they disappear.
1 to 1.
That's what anti-ampicillin means to me.
CH.
It's-
1, 2, 1.
Oh, wait. Oh my god. It's a.
I believe in you.
Crap,
It fits-
I have
it fits
this.
the definition.
Wait,
Isn't that really cool?
Don't give up on me yet. It's.
Yeah, go ahead.
So for the inducer, it needs the aura to what happens when it does have it?
So basically, when this list has arabinose, an enzyme will bind to GFP and it will make the GFP protein.
Oh, I see.
And arabinose does that.
Arabinose. So there are many different ways that this can happen. But basically, a lot of times, the way it happens, and the easiest way for me to explain it to you, is there is usually a protein that binds to DNA, and it can either bind to DNA, and it's called a repressor. It can either bind to DNA, or it can bind to arabinose. So if arabinose is there, it will not bind to DNA. And this will unloop, allowing it to be read. If it's there, it will loop, and it won't be read. Yes, Nico.
Is it an inhibitor?
Is what an inhibitor?
Lactamase?
Not really.
Okay, I tried.
It kind of. So, what is an inhibitor, Nico?
Well, let's see. An inhibitor gets lodged in an enzyme and stops it from functioning. If it's a negative inhibitor.
But what is beta-lactamase?
Well, it's an enzyme, you see.
So,
It's a
So-
code that destroys
so-
AM.
So ampicillin is an inhibitor then?
no. What is the relationship, Toby?
Doesn't beta-lactamase destroy ampicillin?
Okay, so what is ampicillin to beta-lactamase?
The substrate or whatever.
It is a substrate.
Oh.
Right, so beta-lactamase destroys ampicillin. Ampicillin
Stops ribosome.
stops bacterial growth.
Oh, but
Yes, it does that too. I can't remember whether ampicillin it either inhibits cell wall growth in bacteria or it stops ribosome function.
This is hilarious. This is
Ribosome.
exactly what Tripp did. He got to this part in the presentation and said, "I don't remember which one of these two things it inhibits. It's either cell walls or ribosome function."
All right,
You said
you know what?
ribosomes
I'm
last
right,
time.
and it's going to be cell wall.
I think he said the opposite.
You said
Look it up
you
real
said
quick.
ribosomes
I am.
Look it
last
up.
time. You said ribosomes last time.
Thank you.
You're welcome.
That means you're right.
Cell walls. It inhibits the third and final stage of bacterial cell wall synthesis and binary fission. Ultimately leads to cell lysis.
Drop it down.
I am sometimes
but it's
wrong,
only the
Nico.
second attempt that counts.
Okay, so folks, beta-lactamase destroys ampicillin. So if beta-lactamase destroys ampicillin, which destroys bacterial growth, then beta-lactamase
Encourages bacterial growth.
encourages bacterial
This is like the
growth.
physics
Or
thing with the
enables.
vectors, where you do the vector sum, and it's like,
Stop being excited about science. That's not what we do here.
you see what I'm saying?